Hi everyone. In this particular video, we are going to explore what is RNN. We are going to understand RNN in terms of architecture and how it works internally. So when I say how it works internally, it means we need to understand what are the mathematical operations involved behind RNN. We will start by understanding the basic RNN architecture. Before that, we need to understand why we really need a RNN to solve some specific problem. So we will start uh, by exploring the architecture of RNN. Then we will see the basic operation, how RNN work and how it give the output or prediction, whatever you say. And then we'll try to understand how, or I can say, what are the challenges. Okay, let's say if I'm going to train RNN model, what are the challenges which we can face, like vanishing gradient, exploiting gradient, gradient clipping, uh, and to initialize the weight of the each of the layer at each of the layer, we use different strategy. So that we are going to explore in this particular video. And then once we will understand how it, like, what is the architecture and how it work internally and what are the problem or what are the challenges within the RNN, then we will try to implement it from the scratch. So when I say implementing from the scratch, that means we are not going to use TensorFlow or PyTorch. We will implement it by writing our own code. So whatever the architecture we are going to explore, that things we will how we will implement one by one. So just make sure when you are watching this video, just note down all the steps. Okay, like whatever the mathematical operation we are doing, you need to note down those steps. So I'm going to break this video into two parts. In the first part, I will explore about the architecture of RNN, and then I will explore all the key operation, all mathematical operation, and the challenges. In the second part, we are going to implement RNN from the scratch. And also we will implement one real application so that we can understand how RNN can solve some basics problem. Nowadays, everyone is talking about GNAI. That is okay. But at the same time, if you are using any large language models, that will cost you. But RNN will not cost. Okay, so if you know the architecture, you know how it works internally, maybe you can implement it from your using simple Python function. So let's start by understanding what is RNN. So let's understand what is RNN basically. Okay, we know basic neural network. Okay, if you don't know, let's explore that things also. Maybe uh, uh, how neuron work basically. Okay, let's say you have certain input. Okay, so whenever I say you have certain input, it could be any kind of data. Okay, maybe image data, video data, or tabular data. It doesn't matter. You have some certain data, and if you have certain data, definitely, like let's say you have you will get some feature. Let's say x1, x2, x3, x4, x5. Okay, so this is the input for you. And now with respect to this input, let's suppose you have a label data. Let's say you are going to predict something. Let's suppose you're going to predict rating, and your rating, let me write over here, your rating can belong between y1 to y5. Okay, let's say it's a multi-class classification problem. Now you're going to use you're going to create a neural network. Okay, so let's say how we can solve this problem using simple ANN, or let's say using multi-layer perceptron. Okay, if you're going to use multiple layer, how it will work. So let's say the very first thing, what will we have? We'll have input layer. Okay, so at each layer, let me write like this. Let's say at each layer we have certain number of neuron. Okay, one neuron or two neuron. Okay, and let's say these are two two-layer neuron. Okay. And now let's say one is a output and then something like this. So this is a layer 1, this is a layer 2, and this is a layer 3. Okay, so I'm calling this is a input layer or first layer, and this is I'm calling it hidden layer, and this will be your output layer. Okay, let's say now I have to train this model. Okay, so basically what I will do, I will pass my input. So for basic understanding, this will be my input x1, x2, x3, x4. Okay, now what I will do, what I will do, I will take this input, each input. So basically this is from row R1. Similarly, there will be, let's say we have 10,000 data point. So I will pass each data one by one to this neuron. So basically this is called feed forward. That concept I hope you people already know. So if I will pass this input to this neuron, same, I will pass this to this, similarly this to this, and similarly this to this. Let me use some different color now. I will do the same thing for this one, this one, this one, and this one. So we know that, like we already know, just give me a minute. I'm really sorry. So we already know that each of the connection will associate with some weight matrix. Okay, let's say W1, W2, W3, W4, W5, some WN. Okay, so this weight matrix. So at input layer, we will have some weight vector. Okay. Similarly, now, so here there will be some kind of function. Okay, some kind of function it will be. Basically, we call it activation function. It will do something and it will give the output which will pass to the next layer. Will pass to the next layer. Something like this. And now here also you will get some weight. I'm calling like this. Something like this. So here also you will get some weight vector. And similarly here what I'm saying, let's say whatever the output we got from here, from this activation function, and from this activation function, we are going to pass to the next layer. Okay. And now here some weight, and now based on that, we are going to get our prediction. Okay. We will get our some prediction. Now, so this is a way. So here in the data itself, if you observe, let me go to the next screen. So whatever the data you have, so let's say in the data, there are 4 features. Okay, so let's say there are 4 feature x1, x2, x3, and x4. So we have 4 different features. And now we are predicting something. So I'm just calling it y. So in this data, you can observe one thing. This input size is fixed. For each of the row, this input size is fixed. This input size will be fixed. And you will get some of the output, some rating. Okay, this input will be fixed. So to train this neuron, if you go back to train this neuron, what you will do? Just a minute. Okay, I'm really sorry. Just to train this neuron, what you will do? I'm just writing one pseudo code so that we can understand what I'm doing it. So basically, what you will do, you will just iterate over all the point. Let's suppose you have 10,000 point, you will iterate it. You will basically, there's a 2-step which you are going to do it. That is called feed forward. So when you're doing feed forward, okay, basically feed forward is like what? You are passing entire data to your neural network. Okay. And then at time of first feed forward, this weight, so whatever the weight you have, this is like you are using some kind of initialization technique. Let's say you are using some random technique. Okay, you're just populating this weight using some random value. Okay, this will initialize with some random value, let's say, okay, all this thing. So at first feed forward, your weight will be in some random value. So basically you have to update these weights. So basically you have to find out the best weight matrix. Once you will get the best matrix, you will freeze your neural network. You will say this is your best network. Okay, for that one, what we do back propagation. Back propagation is like that like what? So we just compute a differentiation for the loss function. Okay, so we try to minimize the loss. Like in one of the videos, like if you go back when we were discussing about the logistic regression or SAT classifier, then at that time we explore it in the details. Okay, maybe you can explore that video. Okay, so what I'm saying here, so this will be the two-step things. So, okay, I'm not explaining neural network in the depth, but I'm trying to connect one point over here. What I'm saying there, in this data, input size is fixed. It will be always fixed. It will be always fixed. Okay. Then your simple neural network will work. Now, one big question to us. Let's say we are doing some, let me go to the next screen. Let's say we have input. Now this input, this time is a text data. Okay, let's say we are doing some machine translation task or language translation, whatever you want to say. Now we have the text data. You have the text data, and with respect to this text data, you have output, like translated output. Let's suppose you are writing something. You have some certain text over here. And now let's say this is, I'm just writing it R1, R2, R3, R4. And let's say we have 4 input. So now let me quickly just draw it. Okay. Now let's say each of the text. Let's suppose this text have certain number of word, W2, W3, W6. Let me write 4. So let's suppose this text have only 4 word. Now different text will have, let's say something W1, W6, W7, W9, W something. Let's suppose this have 5 word. This have 4 word. Let's suppose this text input have 10 word, and this have, let's say, 20. So if you follow the previous architecture, here what you are doing, you are fixed. Your input layer is like basically you are fixed that you are 100% sure that your data will always have 4 features. Okay, and you have, like this will be the, like your output will be between 1 to 5. Let's say you are predicting rating. Like here in this case, your input size and output size will be always different. Definitely, your input size and output size will be always different. Then definitely the previous architecture cannot work properly. Definitely you can, if you want to adjust it, you can adjust this architecture, and you can try to make this work, but definitely that is very lengthy task. And then what to do now? Okay, then RNN will come into the picture. It will help you to solve this kind of problem. Okay, so let's come again to this screen and understand what I was talking about. Okay, so RNN is like, it's the type of neural network. Okay, it is basically designed for the sequential data. Okay, like in the traditional feed-forward neural network, what we do, we process each input independently. So basically, we take the input, we pass it, and we get the output. Okay, so that is not a case in the RNN. So basically, RNN can remember your previous inputs. So I will come to this point, what to my previous input. Okay, so I will come to this point. Okay, let's leave it. So, and I'm following this article. Maybe I will share this link so you people can also follow this. So let's say what is the architecture. So in the RNN, let me go to my blackboard. Let me. So how RNN work basically? Let's say we're going to explore it. Like as I was mentioning that we'll break our session into three parts. Sorry, two parts. One where we're going to explore how RNN work internally. Like basically we'll explore architecture and the mathematics behind it. So in the RNN, we have three layers basically. One is like in the any neural network, how many layer we have? We have input layer. Okay, we have hidden layer and we have output layer. So basically we have input layer, we have hidden states basically here, and one is the output sequence. So we have to explore this thing. So let's start with the input layer. Just a minute. Okay, let's say how it will work. If I will go back to this example basically, how it is working, how RNN model will work for you. So I'm giving high level overview how RNN architecture will look like. So let me go to the next screen. Let's consider the previous input. Let's say let's consider this input. Let me write it again. So we have, let's say I'm calling R1. So you can consider the input number 1. Let's say this input have certain word W1, W2, W3, W4, W5. And the next R2, we have something like W6, W7, W8, W9, W10, let's say. And now with respect to this text, let's say this is one text we have. We have equivalent output. Okay, I'm just calling out W1, W2, W3, W4, W5. We have equivalent output. And now with respect to this input, also we have some output. Okay, now we have something like this. So this is a very simple example, which I'm going to explain over here, how RNN model will work. So how this will work? So you are not going to pass entire things in one go in RNN. It will process your input one by one. How? So basically this is a one input. This is one input. This is one entire input. So first what you will do, whatever the input we have will convert into the vector. So that this is W1. I'm talking about R1, R1. So what we'll do, we'll convert into the vector. So without vector conversion, definitely we cannot pass it to the neural network. And then we'll pass to the one layer. Okay, let's say we have certain number of neuron over here. This is only one vector I'm passing it. And now we'll get one equivalent output. Let's say some output y1. And what I will do, whatever the output I'm getting over here, I'm going to pass it to the next layer. Now the next layer will process your next input. That is what? It will process your W2. So you will convert into the vector and you will pass it to the next layer. You pass it to the next layer. Let's say something like this. You'll pass it and you'll get the output. Let's say Y2. And now similarly, so basically here, what you're doing, you're remembering the previous state. So you can call it like basically you're trying to memorize it. Okay, so basically you're trying to understand what happened in the past. Okay, so you're learning it. So you are taking the previous information also. What was that? And whatever you have learned, you are passing to the next one. So basically you call it hidden state. So you compute the hidden state multiple times. Now, whatever you learn over here, you are going to pass it to the next layer. Now see, all this layer are connected to the previous one, definitely. So this one, this one, this hidden state will have the information of previous one as well as previous this one also. Okay, now we'll do like this. We'll pass it. I will convert the vector and I will pass to the neuron network and we'll get y3. And this step will continue till the number of what we have here. And at then we'll get the output. For the output, we'll explain how we'll get the output over here. So we are going to pass it to some final network and that will give you the output. Okay, something like this. So now let's understand this thing in more depth. Okay, like this is a way like how neuron will work, how RNN will work. So in the RNN, we have three things. One is like input layer. So at time of input, what is happening? It is not passing entire input in one go. Like if you go back to the simple neuron, what is happening? You're passing entire input in one go. It is learning, and then you're passing the next input. Not like this is not this will not happen in RNN. How it is going to learn? It will take each input separately. It is a sequential things. Okay, it is learning from the previous thing. Definitely, it cannot see your the past future things. Okay, so that information it will not contain. Okay, so for an example, let's say W3 will occur over here one more time. So since this information is already captured by this architecture somewhere, let's say here, but after capturing the W4, maybe he will calculate again. That is like, we don't require to do it because we have already captured it. Okay. So this is about architecture. So as I was explaining, let's see how it will work. Just give me a minute. Let me share the complete architecture. Okay. So let's discuss it. So how was explaining that this input you can consider as W1, you can consider W2, W3, and W4. Okay, these are the input you have. Now you're going to pass it. So as I was explaining that here you will get some weight because definitely you're going to pass to the neuron. So this connection will have some weight matrix. It will have some weight matrix. So basically the same fundamental idea which you have for any neural network, here everything is same. So only difference is that this will process data in the sequence order. Okay, that is the only difference. Now each of the things. Now what is happening? Like if you're passing the input along with your weight matrix, what is happening? It will generate one output. It will generate one output, and now we are going to store it some information which we learned from the previous layer. Okay, and we are going to pass it to the next layer. We're going to pass it to the next layer, and now we are going to pass the second input. So basically, this is R1. What I was tracking. So here we have 4 different words. Let's say. So each of the things, so whatever learning you have learned from the previous word, you're going to pass it to the next word. And whatever the learning you have learned over here, you're going to pass to the next layer. This is a sequential things you're doing it. Okay, something like this. And now here, when you're starting it, so you have to initialize your hidden states. So the similar way which you are initializing your weight matrix, the same way you have to initialize your H value. And you can use any of the technique. Okay, you can initialize 0 also. Sure? I don't think. No. Okay. So you have to do all these things. So it will go like this. And now you will compute the hidden state at each layer, basically. Okay. Hope now I'm making some sense. So in the RNN architecture, we have 3 things. One is input layer, other is the hidden state, other is the output. Okay. Okay, so this is a basic structure. So at any of the stage, okay, when I'm talking about hidden state, what you're doing basically, you're computing, like basically what you're doing, how you're computing this hidden information. So you are passing to any kind of function. It is activation function. And what you're doing here, taking your input at any state at time t basically. So at time t, let's say you are passing the first input, you are passing to the matrix. And now what you're doing, you're taking this weight matrix and you are computing with the previous one. So this is the kind of loop you are doing. And now you are just adding with the bias. Okay. So this is like this information which you learned from the previous layer. Like here in this case, what is the previous information? HT minus 1. This will be the H0. And whatever the information you have to multiply with your weight vector. This is a weight matrix basically. So here U, W, you have to compute it. And this bias also, you have to compute it basically. Okay, so this is just a high level overview how it will work. Just a minute. Okay. So how I'm going to define the hidden state? So let's say if I'm going to code it, okay, like at some point we have to code, we have to develop RNN from the scratch. So we need to understand how we are going to define the architecture. So very first thing, what you have to define, you have to define your H0. So how I'm defining, I'm just giving one simple example. Okay, so, and we have to update this hidden state. We have to add this hidden state every time. And how I'm going to do it? I'm just writing the one simple for loop over here. So first I'm initializing my hidden state, S0, and then I'm going to update it. So how I'm doing it? This is the same things. This is just a formula which I copied. This is the same formula. If you observe this mathematical equation, this is the same thing which I'm going to write into code also. So this is your input. And with respect to that input, at that layer, whatever the weight matrix is there, you're going to multiply it. This is basically dot product. I forget to write, just forgive me. And similarly here, whatever the information you learn from the previous, you'll take it, you'll multiply with the weight vector. And you're going to do it. Whatever the bias you have, you're going to do that. Once you learned it, you're going to store it into one of the list basically. Basically, there's a dictionary which I'm going to use it. You're going to use like, this will define the state. At which state, what hidden information you learned basically. What are the information you capture, that we're going to store it. Okay, hope I'm making sense now. So when we will start writing the code, definitely this will help us. So always remember, whenever we are exploring any kind of architecture, always understand mathematics, how it works internally. This is just only one thing. Okay, this is just a hidden information, because at the end we have to need output. So this will be the very first stage where we have to understand how this hidden state will compute. And also remember, we have to update this weight. So like any kind of neural network, what we do feed forward, and then we do back propagation. So in the RNN, we don't do the traditional back propagation. Okay, we do propagation with time basically. This is very quite different from a traditional neural network. We'll come to that point. Okay. Okay. So, and now your output, like in RNN, your output could be one to many. So this, if you pass one input, you may get multiple output, maybe many to many or many to one. Okay, you can get any kind of output. Now, to compute the output at any step, basically at time t, you can calculate like this. So this is a hidden information which you learn. And now this will be the weight matrix to output layer basically. If you multiply it, you will get this like this. Let's say if you're doing any classification task. Okay, so you can use soft max function. You can pass to your soft max function. And basically what I'm saying, that what will be the, basically what is the probability of this input, let's say some input we have, to be class 1 under this information. So we are passing the hidden information also. So it will predict like this. So hope now I'm making some sense. So we know that what are the key operations we are going to do into the any kind of neural network. So first we are going to do feed forward. We know what we do in the feed forward. So basically we initialize hidden state, weight matrix. Okay, initialize it. We are going to pass each of the input to this neural network. We are going to compute the hidden state at each of the time. Okay. And then we are going to compute the output. Basically, this output, we are going to compute it at each of the state. Okay. That is the case. Now, the second operation, which is like I was talking about in the any neural network, we have to now, we have to come for like optimal value for this weight matrix. To get that optimal value, what we have to do, we have to compute the loss function. So we are going to compute the loss function over the time, and we're going to differentiate it. So basically, we'll compute the differentiation input to hidden layer, and then hidden to hidden layer, and then hidden to output layer. We are going to compute it, and then based on that, we are going to what I'm saying, you have to modify it, your weight vector, something like this. So this is all about how RNN architecture will look like. So I will share this document. Maybe this will definitely help us to understand in more depth. The same architecture I'm going to use to write the code also. Okay. So hope now I'm making some sense. So I hope the RNN architecture is very much clear. So forward pass, which I explained, and we know that. So we compute the loss function to update our weight matrix. Okay. So in one of the videos, I explained how back propagation works. So this is very similar to the back propagation, quite just little bit difference because here we compute the gradient at each step, basically. So you can explore in that particular video. Okay. So there are some problems, or I can say there could be chances that let's say at each state, let's try to understand what is a vanishing gradient. Okay. Let me go like this. Let's say you're doing some operation. Okay. At each state, let's suppose at time t1, you got gradient value, like differentiation value, you got 0.001. At time t2, you're going to get 0.0001. At time t3, you got differentiation value 0.00001. At time t4, 0.000001. Now let's say if you're going to do product of all this thing. So basically, if you do the t1 into t2, t3, and t4, what will happen? Your value will be very, very small. So basically, your gradient, okay, will be 0. And this lead the problem. This can lead the problem. So we have to make sure that we have to avoid all this thing. And how to avoid it? We'll see that point. Okay. So let me quickly go through the. So when training RNN using back propagation, the gradient of the loss function are passed backward through the network to update the weights, which I was talking about. In deeper network, so if you have very deeper network, okay, so if you're computing the gradient, and let's say your gradient is decreasing exponentially, okay, and then what will happen at some point, you'll find, okay, it is approaching to 0. Okay, this can cause 0. Now this will your network cannot learn properly. It will not able to update your weights properly. And definitely if you have very long sequence, definitely this can cause the issues. Okay, so successive multiplication if you're doing, definitely like which I was showing over here. If you're, let's say if you have a very long series at each state, if you're doing the calculation, it will be very, very small. Then this is a problem. This is definitely a big problem. Okay, so you have to make sure like this. If you do the reverse of it, okay, if you at each state, if you're getting very large value, what will happen? You will get very large gradient value. That will also not a good sign. Okay, so let me read like this. If gradient is very large, greater than 1, then can increase exponentially at time of back propagation, and this can go to the infinity. This is also a problem. At time of training, you have to make sure Like this is not going to happen. This is one of the things which you can learn, that is called gradient clipping. So you can clip, like basically you can decide what should be gradient. Okay, you can clip it. So if you want to avoid it to be very large gradient, you can use the gradient clipping method. By keeping the gradient within a defined range, it ensures that they don't cause to update to become too extreme weight value. Okay, so we are going to implement this one. Okay, so I hope now I'm making some sense how RNN will work and what is the RNN, wow, the architecture of RNN. In next video, we are going to implement it. We will write the code together and we will see it. Thank you.